Welcome back once again. In this lesson, we're going to take a look at securing virtual machines, and what this discusses is the variety of additional support mechanisms that vSphere has added to add additional security features for our VMs. What this means most notably are things that have been added to the ESX servers for managing at the VM kernel level, but we can also present some of these to the guest OS. So that means we can provide to the guest things like secure boot, a virtual TPM device, virtualized based security, and something called vSGX. So let's take a look at what all these are. These are relatively recent enhancements in vSphere from the 6.5 version and onwards. So first up is the ability to allow the guest OS to have their own secure boot. We did talk about this briefly when we talked about the whole vSphere Trust Authority, how an ESX server could be booted securely by updating the BIOS of your ESXi host. Well, what if we could update the BIOS for the VM that offers the same basic capabilities? And sure enough, we can do that. You have to make sure that the VM has been set to the EFI-based firmware. If you've done that, you can enable the VM's virtual secure boot, right? So you'll note here, if you've got EFI as the BIOS, then you've got the option to enable secure boot. The other requirements is that the VM needs to be using hardware version 13, which is basically what you need with vSphere 6.5, right? The guest OS supports the UEFI secure boot process, right? So, modern versions of OSs, and you just have to verify with your guest OS. But the great thing here is that we'll start the process for secure boot, and then the guest OS basically takes it from there. So the guest can then boot itself in a cryptographically clean way. But just like in vSphere, secure boot in vSphere 6.5 is great. The server, in the case of an ESXi host, will only boot the ESXi host if it passes the secure boot verification test, right? But what about being able to remotely attest the ESX server? What do we need? On the ESX server, we need one of those TPM 2.0 devices. In a virtual machine, we can present to a guest OS a virtual TPM device. So that's not a real chip, right? That's a lot different than the TPM device, right? The TPM device is an actual thing that, a chip that sits on the ESX server's motherboard. It's a real piece of hardware. A virtual TPM, there's no dependency on having your server to be, containing an actual physical TPM chip. You don't need any real physical hardware for the TPM. To have the virtual TPM, what we're doing is we're basically making a modification to the NVRAM file. So we're just making a modification to a file. Now what we'll do here, right? This is from vSphere 6.7. And so we can actually use a virtual TPM device to record the stages of the guest OS's secure boot process. The guest OS can also create and store private keys in such a way to then never expose those things to the guest OS because of the crypto capabilities of this virtual TPM device. It can use private key for encryption or signing, and with that virtual TPM device, a third party can remotely attest to basically validate the identity of the firmware and your guest OS. So the use cases, right? An operating system can verify that the firmware loaded was not compromised since the last run, and an application can verify that the operating system did not load any malicious components. So we're actually providing a very similar capability to the guest, just like a real TPM chip would be provided to an ESXi host. Now, that's sensitive information, right? The stages and the cryptographics and the keys and all that. So this TPM file that is going to be generated for this virtual machine needs to be encrypted. So in order for this to happen, your environment must be associated with a key server. Now, this could be using the standard KMS servers, or it could be potentially coming from a trusted key server. That part shouldn't matter, but the TPM file needs to be encrypted. So you basically need an environment that is registered with a KMS server. And what will happen is the entire set of files of the VM, minus its virtual disk, right? So it'll actually be all the files of the VM will be encrypted through this key exchange obtained from the KMS server that's registered with your environment. If you wanted to actually encrypt the virtual disk, you certainly can, but that is actually leveraging VM encryption. So This is focusing on the virtual TPM and the surrounding files around it. So you can back up a VM, by the way, that's been enabled with a virtual TPM. The backup must include all the VM data, including the NVRAM file, since that's actually where the virtual TPM sits in. And if your backup does not include the NVRAM file, you cannot restore a VM with that virtual TPM. And because the VM home files are encrypted, you must ensure that the encryption keys are available at the time of a restore, right? The KMS server needs to be available at this time. You can remove a virtual TPM from a VM. However, removing that will cause all unencrypted information on the VM to become unrecoverable. So careful here. Before removing the virtual TPM, disable any applications in the guest OS that were using that virtual TPM. Now, the significance of this, you have both secure boot for your VM and you have a virtual TPM available for the VM. The ways in which this is really, really useful is with a topic coming right up called the virtualized base security that Windows has. So just a few other prerequisites with regards to a virtual TPM. Everything needs to be running vSphere 6.7 or later. So your ESX servers and your vCenter server, and you need a key management server that has been registered with your environment so that it can actually encrypt the key for the virtual TPM and the rest of the files encryption. For VMs, you need to be running the EFI firmware. In fact, with a virtual TPM, the VM needs to be doing secure boot. It's kind of like the whole point of why would you have a VTPM in the first place is because you're running secure boot. So you need to be running with EFI firmware because EFI firmware supports secure boot and it also supports this virtual TPM. Your hardware needs to be hardware 14 because this was introduced in vSphere 6.7, whereas secure boot required just hardware version 13. And the guest OS, in order to give a VM a virtual TPM device, it must be a Windows guest. So Windows 10 or Windows Server 2016 or later. And wonder, why is it with Windows only? Well, you know what it is. VMware actually has been working with Microsoft to really be able to support this next topic, VBS. This is a Windows developed mechanism. Virtualized base security for Windows guests. What this is, if you look at our example here, there is a Windows VM in the green box, right? And so with Windows, it already has Hyper-V built in, right? The Windows hypervisor. And with their virtualized base security, what Windows is capable of doing is actually taking the traditional operating system access and files and drivers and libraries are all held in the main OS memory, but then certain secrets, credentials, keys, and cryptographic information, they would be isolated in another area called the credential guard, or sometimes just known as the cred guard. But it's using the hypervisor's level of isolation to keep the operating system and all of its files and services in one secured area, and then the credential guard isolated off into another area. And so in order for the credential guard to be established, that Windows operating system needs to be booted securely. It needs to be booted into a trusted configuration. So it needs the ability to be securely booted. It also needs to have its boot state and identity verified and attested by a central authority. So you need a TPM device in this Windows OS. And so basically with VBS, what Windows has done is they've created this isolated area for the credential guard, keeping secrets even separated out from the operating system, but done in a place where the operating system is trusted with secure boot and with a TPM device to provide the cryptographic assurance and the remote attestation of that. So the goal here was, okay, Windows is doing this. Can we do that in a vSphere virtual machine? So we're nesting virtualization here, if you can imagine, right? If you're going to run a Windows virtual machine on vSphere, we've got the vSphere hypervisor, but now Windows is a VM running its own hypervisor, basically running the credential guard as a separate isolated entity. The only thing is, in order for this to work, this nested virtual machine, which VMware has been doing for quite some time for ESX nested virtual machines, but this is a Windows nested virtual machine, you need to have VM hardware presented to this Windows machine that is capable of providing the requirements for VBS. So that means the VM needs to have hardware virtualization enabled, which is a feature of vSphere anyway. You need an IO MMU, which is part of nested IO management. You need secure boot and you need a virtual TPM. So all of these devices and virtual devices need to be configured for the VM in order for the VM to support VBS. The thing is, this is all things that we've been doing in vSphere 6.5 and 6.7. All you really need to make sure you have on vSphere is that you're running at least 6.7 because that gives us the support for a virtual TPM. You need a registered KMS server so that we can provide the keys to encrypt the virtual TPM and the rest of the files that belong to the VM. And then you simply build this VM with the setting, it's a VBS protected VM. That part's pretty easy. So again, we have our requirements and limitations. The VM must be a hardware version 14, which is the hardware mapped with vSphere 6.7. The guest OS must be either Windows 10 or Windows Server 2016. The VM must be on an ESX host running 6.7 or later with compatible TPM device installed and enabled for VPTM support. That's not entirely true. You don't need the actual physical device TPM. What you need is just the ability to have a KMS to create the virtual TPM file. VMs that have VBS enabled use UEFI firmware and secure boot by default. The things you don't get, though, when you run VBS is the VM cannot be protected by fault tolerance, and the VM can't support PCI pass-through. But like I said, enabling VBS, as long as we meet all the prerequisites, is actually pretty simple. As you're creating the virtual machine and you're selecting the guest operating system, you choose the Windows family, you choose Microsoft Server 2016, and then you check the box. You want to enable this for Windows virtualization-based security, and then it will build the appropriate virtual machine hardware automatically for you, right? Provided you have the KMS. That's the other big prerequisite. You need a registered KMS with your environment so that we can then use that to generate the key that will be used to encrypt the files, including the virtual TPM. So that's a quick look at some of really cool features that were added in the 6.5 and 6.7 timeframe. We'll take a quick break, and then we'll come back and take a look at what was added in vSphere 7. So see you in a few minutes.